What You Never Knew About Soap by Katie McDonald,
Megan Bowers,
and Jenna Rickert.
The earliest forms of soap were discovered in 2800 BC at Sapo Hill in Rome. They are made out of water, alkali substances, and cassia oil. What happened is the women washed their clothes in the stream at the bottom of a hill, and at the top of that same hill there were animal sacrifices that took place. So the lye and fat from the animal sacrifices mixed with the clay on the hill, and it ran down to that stream, and that was kind of like a soap. In the Middle Ages, soap was made by mixing animal fats with lye, and it could lead to serious injuries like chemical burns or even blindness. So to make things safer, sometimes ashes from fires were added to the soap. The plant ash idea was also used in early soap production. Plant ashes contain potassium carbonate, and they were dispersed in water. Then fat was added to the solution. More and more ashes were added until the water would evaporate and boil. This is an early form of saponification.
You can now see on the screen a simple general formula of how soap is made. Simply, you use an animal or vegetable fat or oil and add lye, which would make soap and water plus glycerin solution. The basic structure of all soaps is a long hydrophobic hydrocarbon, which is a water-fearing hydrocarbon, and a hydrophilic anionic head, which is a water-loving head. Triglycerides and fat or oils are heated in the presence of a strong alkali base, which is normally sodium hydroxide or potassium hydroxide, and this produces 3 molecules of soap for every molecule of glycerol. This is the normal process of saponification. Soap can technically be defined as the alkali salt of a fatty acid. Lots of different fatty acids are used in soap. A fatty acid is a long chain of carbons with single bonds to each side to a hydrogen atom. And then, at the end of the long chain of carbons, there's a carboxyl group made up of a single carbon, 2 oxygen atoms, and a single hydrogen. And this fatty acid can either be saturated or unsaturated, which can affect the type of soap. Oils and fats are also used in making soap, but there is no large differentiation between fats and oils besides the fact that they are different substances at room temperature. In order to manufacture soap, you have to find the distinction between these fats and oils. But the hydrocarbons used cannot be in the manufacture of soap. Animal fats and vegetable fats do contain the necessary fatty acids, though, that are needed to make soap, and these fatty acids are used in the form of triglycerides. Triglycerides are necessary in the manufacture of soap. A triglyceride is when 3 different fatty acids carboxyl groups are combined with a glycerol molecule. The physical characteristics depend on which fatty acid is combined to the glycerol. If an unsaturated fatty acid is contained in the triglyceride, then it's going to be an unsaturated fat. The type of fatty acid will also determine if the triglyceride is solid or liquid at room temperature and other qualities that are necessary. These qualities that are determined by the type of fatty acid will also contribute to the qualities of the soap.
Lye is the final ingredient needed to make soap. Lye is a caustic alkaline chemical, which means that it dissolves in sticky substances like fat and has a high reactivity with other materials. Lye is created when sodium carbonate and calcium hydroxide react with each other. In a raw form, it is made into solid flakes, chips, or grains. In flake, granular, or liquid form, it can be very dangerous and cause damage to surfaces and people, and this is why that some cleaning products are toxic to people. So this is how soap works. Soap is an emulsification agent, which means that it is a process of disturbing one liquid into a second immiscible liquid. Immiscible means that they can't combine with each other. For example, water and oil. Water is polar and oil is nonpolar, so they repel each other and separate. The fatty acids and oils combine with the oil on the skin and clothes since they have similar polarities. When the oil from the soap combines with the oil on the skin or clothes, it loosens from the skin. When the oil and dirt are run under warm water, it washes off because it has been pulled from the skin and the oil in the soap.
The end.